Let's continue talking about data manipulation in R. This is part 2. We'll be focusing on data restructuring and transformation. In the last video, we worked on a data frame made from the built-in dataset, air quality. Still working with this data frame, we can add new columns by just directly naming the new column using the $sign. I'm converting the temperature column, which is in Fahrenheit, to Celsius using this formula, and I'm assigning the values to this new column. For multiple columns, instead of assigning values over several lines like this, you can use the transform function to make the code cleaner. In the transform function, you give the name of the data frame once, then refer to the columns by their names. This way, you avoid writing my dat $sign over and over again. Note that when I assign just a single value to a column, the value will be replicated across all rows in the column. There might be cases where you want to sort your data by a given column. To do that, use the order function. For example, if you want to sort the data frame by values of the ozone column, first you use the order function, which will return a vector containing the original row numbers in the sorted order. Let's say 3 is the first element in the returned vector. Then it means that the third row in the unsorted data will be the first row in the sorted data. You can also give the order function multiple columns, and the function will sort by the first column first, then by the second column, and so on. By default, the values will be sorted in ascending order. Put minus before the column for descending order. Using this vector of row numbers as the row index in the square brackets effectively selects the rows in the same order as they appear in the vector, thereby sorting the data frame. You'll notice that the row names, which are the original row numbers, are out of order after sorting. To reset them, assign the null value to the row names. This will trigger new row names being generated, starting from 1. There might be cases where you want just a subset of the data. In addition to using square brackets specifying the rows and columns to be selected, you can use the subset function for cleaner and more readable code. Just like the transform function, my dat $sign won't need to be written multiple times in the subset function. Use the select argument for columns and the subset argument for rows. Note that you can use conditions to subset. Here I'm filtering for all rows in which the temperature in Celsius is greater than 33 and the wind speed in kilometers per hour is greater than 10. For multiple conditions, remember to use the vectorized and or operators. There might be cases where you have data in different data frames that you want to combine for analysis. In the simplest cases, you can combine 2 data frames by rows or by columns if they satisfy certain conditions. To combine 2 datasets with the same structure, meaning they have the same number of columns and the columns have the same names, you can essentially stack one dataset on top of another using the row bind function. For example, here I created a data frame with just the columns month, day, and ozone, containing data from the month of May, and another data frame with the columns month, day, and ozone, containing data from the month of June. They can be directly combined by row. To combine 2 datasets that contain different variables for the same individuals or rows, you can combine them side by side. Here, I created 2 data frames, both containing data for the same days in the month of May, but one data frame is ozone data and the other is temperature data. Because they have the same number of rows, they can be combined by column using the function column bind. More complicated merging of data frames can be accomplished using the function merge. If 2 data frames have one or more common columns, for example, a column of unique identifiers, only rows that have matching identifiers in the two data frames will be retained and combined by column. This is called an inner join. As an example, I created a data frame of ozone data from the second half of May and another data frame of temperature data over the whole year. Performing an inner join on these two data frames will retain only those rows that are in the second half of May. Merge can be used for other types of joins, where all rows of one or both of the data frames are retained.